All right, so we're going to go ahead and get started. This is it's a huge honor to welcome our guest speaker, Yin. He graduated from University of Rochester with a BA in mathematics, and he then completed a master's degree in statistics at Columbia very recently, and he's now going to be transitioning to a PhD program there as well. He also worked as a quantitative analyst at AQR Capital, which is the world's largest quantitative hedge fund, and then he founded his own firm, Yin's Capital. And the interesting thing about it is it's like he's using a combination of like human and AI inputs, which is going to be something very interesting as the industry is transitioning to machine learning. He also has an amazing YouTube channel. So he's got like 60 videos, and like a lot of them are very focused on quantitative finance. So it's definitely something I would recommend that you guys check out. So the format for today is going to be, he's just going to present like different machine learning techniques he's found to be practically useful, especially using the Python libraries that are definitely something that you guys can get your feet wet with, even if you're not like extremely experienced with programming. And then we're going to have like a decent Q&A session, so definitely feel free to ask a lot of questions. All right, without further ado, Yin, you can go.
Cool, thanks. Thanks, I appreciate it. Happy to be here. And happy to speak with all of you. I still remember when I was in Rochester, we actually don't really have a quant club. It's just called an investment club. And then we didn't actually use Python. We just using, spreadsheet, like, Excel, that sort of thing. So it definitely wasn't as advanced as what you guys are doing right now. So yeah, so definitely happy to hear what you guys are doing and the kind of progress that we're making over the past few years. After I left U of R. So all those are positive signs. So definitely great thumbs up for you guys. So yeah, so just like a general overview of what I've been doing from U of R and out of U of R. When I was in U of R, I remember I bought my first stock in September of 2010. I was the freshman year. I just came to U of R. I believe it was the first month, end of the first month, so end of September of a freshman year. I went to the Scottrade down Crittenden, I think. I forgot the street, so correct me if I'm wrong. There's a Scottrade brokerage firm in Rochester, in the city of Rochester. So I took the zip car, I drove there, and then I took my, I have everything except my passport. So I thought I was gonna open up a brokerage account on day one, but I ended up not getting my brokerage account. So I had to go back and then go back again, do a little bit back and forth. But yeah, but anyway, pretty much since October of 2010, I'm in stock market. I've never left stock market. I believe time is the value here. Technology, code, quant, all this stuff you can teach yourself. If you can't teach yourself, go to a school, go to master program. There, people can teach yourself. But experience is something that you can learn, and that's something that you have to collect from yourself. There are some people who don't believe that. If you don't believe that, in simple statistical term, in machine learning, we want data, right? We're looking for data. Data is important. Data is everything. You have a biased data, it's very difficult for you to come up with an unbiased machine learning technology. So it's same with that. When it comes to trading and money management, you are in charge of your own data. No one's going to understand you better than yourself. So that's your responsibility to collect your data. And it's not going to be data from me or Warren Buffett or Jimmy Buffett or whatever Buffett that you're looking at. It's going to be data on yourself. So make sure you have that nailed down, and make sure that if you make a mistake, when I say mistake, I meant that, let's say today you want to buy something. It doesn't matter if it's a quant decision or if it's a value investing decision. It doesn't matter what reason it is. End of the day, you bought something. Right? That's a decision. That's a decision made with real money behind it. Then either you make money or you lose money. If you lose money, let's say stock goes sideways or stock goes down, and then you say, oh my God, I can't take anymore, I'm gonna get out. You take a loss. You better write that down. And then here's how you think about it. You think of it, there's two possibilities. Number one is it's an honest mistake. It's a mistake worth making. And the stock market go down, you take the risk, you take loss. That's fair. That's fair game. It happens. You accept it, right? So that's one thing to look at this. Another thing to look at this is you did something wrong. You did something fatally wrong, and either somewhere in your analysis it didn't make a whole lot of sense, or somewhere in your quant strategy you made an error. It could be a human error. It could be a coding error. It could be a quantitative error. It could be some sort of error. But at the end of the day, it's a mistake. It's a mistake that you had to take, and then you pay for that. So now here's a problem. In statistical term, there's type 1 and type 2 error, right? So one of this mistake is a type 1 error, and the other one is a type 2 error. Then you better figure out a way to nail these two down for yourself. So that's one thing I wanna throw out. And that's unfortunately not a whole lot of people can help you. It doesn't matter if you go to MBA, it doesn't matter if you go to a quant shop, it doesn't matter where you go. You are the only person who can help yourself with that. So yeah, so that's pretty much the highlight that I want to point out. Especially that you guys are young, you guys are still in college, you guys have time. Definitely take the time to collect your data. And once you have your data, you can start with a lot of things. You have a lot of options. You have all these tools to help you understand what kind of money manager that you are. Yeah, so that's that. And let me jump out of money management. Actually, hold on. Let me before I move forward. Any questions about
I'm
that?
getting hungry right now. I'm getting hungry.
You're getting hungry? All right, maybe someone's mic is unmuted. All right, before we move on, any questions about that?
Yeah, I have a question. Like, could you explain like what's the difference between a type 1 and a type 2 error?
Yeah, so I believe type 1 error is what was this? The false positive, and then the other one is a false negative.
Mm-hmm.
So the positive and negative here, it's talking about the mistake that you made. It's a little bit naive. You can separate more levels if you want, but it's a little bit naive kind of category. Either this mistake is fair, that it's gonna happen and you're just gonna have to take it, or this mistake happened, it's something that you can avoid. And I said just my initial understanding is it's one or the other. Later on, I found out actually there are multiple different levels. But I would say in the beginning, don't overcomplicate yourself with that. Just think of it as here you lost money. This lost money, is this loss something that you have to accept, or is it something that you could avoid it in the future, in the past, and then that in the future you should avoid it. So just make sure you understand the difference between those two things.
So would an example for that be, say for example, you have some kind of error in your execution that you could have avoided, right? You set a limit order instead of a market order. Would that be an example of, the bad kind of error versus, something like you have a quantitative model that, is winning 70% of the time, and you're just going to have to accept those 30% losses?
So yes, so Joe, you brought up a good point. So let's say you have a quant strategy that works, let's say 75% of the time. Then what that means is the other 25% of the time you kind of have to take a loss, right? So those losses, so here's another assumption that you have to make. If you are strictly trading this quant strategy, okay, when I say strict, I mean like no fear, no hope, none of that human stuff, just 100% robot, right? Then the 25% of the time that you lost, it's going to be an honest loss. It's going to be a loss they have to take to pay for that 75% that you make money. Now, that being said, I can say from experience, I've never seen anybody 100% trading algorithmic trading strategy. There's always going to be some sort of human decision involved. Even if it's not a human decision, even if it's something as simple as I'm sitting here, I turn the machine on, and then if something does not look right, I turn it off. That's still a human interaction that cannot get factored out. How do I know that I turn it off because I'm rational or because I got scared? You can't say that. There's no science behind that, right? This minute I turn off or this minute I turn it on. Who is it to say that if I turn it off, I'm not scared? Who's to say that if I turn it on, I don't have hope? Right? All these behavioral stuff, you can't mitigate that. So it is up to you to diagnose for yourself whether that money lost is coming from that 25% of the fee that you had to pay for the trading strategy, or like one day you just feel happy and you turn the machine on. So that's something that you have to deal with.
Yeah, that's awesome. Thank you very much.
Any other questions? Okay, great. Okay, so that's quant trading strategy. Let me jump out of the picture a little bit. Another area of aspect I want to mention is career change. When let me just share with you my point of view. As you guys know, I have education both from Rochester and Columbia. I'm lucky to be involved with these two institutions. Rochester, I don't know how how it's doing right now. When I was in Rochester, it still follows Pharma French, still follows Chicago University, so it still follows those big guys. And I don't know if you guys have taken classes with Novi Marks. He's a professor at Simon Business School, and he teaches capital market. He teaches investment. If you, I don't know if you guys can take that class right now, but when I was in Rochester, I can take that class. You know, he got me the position at AQR. He was the guy who got me into asset pricing, got me into algorithmic trading, things like that. So I was lucky to start my money management career from him, which is very great because right off the bat, I have something quantitative. I have something statistical, and I measure all my errors. I measure all my data. Everything is documented correctly. Later on, I went to Columbia. I didn't get to stats in the first place. I actually approached a professor in Columbia Business School. I thought I was going to go to PhD program there. So I approached this professor, and then he is actually a big guy of value investing. He's never touched computer code in his entire life. He met with Warren Buffett once a year, and he reads a lot of annual reports. Like I'm talking about reading annual report like diaries, like the little books or videos that you watch before you go to sleep. This guy is just like, I don't even know how to describe that. It's huge on reading books. And when he reads books, he can draw a lot of correlation that he's seen in the past. And he does comparative analysis, and he's an expert in doing that. Like he's capable of opening up, you point out any page in, say, the annual report of Coca-Cola, he's able to bring up the exact kind of topic that's written in the annual report of, say, Monster Coke or Monster Soda or the other companies that is in the same industry. So he's very good when it comes to that. Now, of course, right now you can say, hey, we have natural language processing, right? We can take care of text, we can take care of sentiment analysis, we can take care of all of that. But to get to his level, we're still far from that. So that's another thing I want to point out, which is this combination of quant and value investing. From my experience, you don't really want to stay on both ends of the spectrum. You want to be able to wiggle around in between. That's my honest recommendation for you guys, which is to don't pick a side. I think picking side is stupid. Don't pick a side. My famous idol is Bruce Lee, right? So Bruce Lee is famous at Jeet Kune Do. He developed it, he founded it. But like, why is that famous, right? It's famous because it mixed with lots of things together. It has Muay Thai, has boxing, has Taekwondo, it has Jiu-Jitsu, right? It has all these things mixed together. So when he fights someone, he's able to immediately identify the person's background, and he's able to apply what he has to tackle the person's weakness. So I think in money management is exactly like that. You don't really want to pick a side. You can't just look at the technical chart and then expect to make money every day. Conversely speaking, you can't just read the annual report and then expect to make money every day. And then you can't just expect to type a few lines of Python code and then expect to make money every day. It doesn't quite work that way. You kind of have to be wiggling in between, or knowing a little bit of everything, and then form your own opinion. That's what I wanna. That's the second thing I wanna throw out at you guys. So make sure you have that nailed down. And I know it sounds difficult because who can know everything, right? It sounds difficult, but it's never too late to start, and definitely make sure you have that faith, have that belief for yourself that eventually you're gonna get the idea that everything start to look similar. The more things that you learn, everything start to look a little bit similar, and you need to get to that level, and you want to get to that level as fast as you can. Yeah. So that's that. And so let me pause here. Any questions about that? Any questions about quant, or any questions about value investing?
Yeah, I had a question. So you talked about building quantum mental models. Now we know that fundamentals are like important, and quantum mentals at places do well, but like, is there any other kind of analysis which would be helpful to mix with quant? Like, I don't know. I mean, anything else which is also like worthwhile looking into and like blending in with quant?
When it comes to natural language processing, or in the field of natural language processing, you can look at the sentiment, like Twitter sentiment, or Wall Street Journal sentiment, or Financial Times sentiment, or whatever social media that you can find online. You can extract sentiment from any of these texts, and then everything else follows. You just convert your text into tokens, and then the tokenized text, which is just a bunch of numbers, and then that's going to be your data for your NLP model. And the NLP model can be as simple as a long short-term memory, or you can go to some hierarchical model, hierarchical RNN, and things like that. And then from there, you can generate some sort of output. And then you can talk about regression problem, or you can talk about classification problem. Classification problem means in levels. The stock goes up or down. That's a classification model. If it's a regression problem, then you're trying to predict the continuous variable. So you're trying to predict, 2%, 3%, or -1%. That's a continuous variable, which means it's a regression problem. You can define all these setup. It's actually not hard to define a setup. It's hard to define the setup that's helpful for you. Yeah. For me, if it's a classification, I look at least 4 levels. Okay. I almost don't look at regression problem. Sometimes I look at regression, sometimes not. I mostly look at classification problem. But no more than 5 or 6 levels. Most likely going to be 3 to 4 levels.
You mean 3 to 4 classes?
Classes, yes. Yeah.
Okay. Just to like follow up on that, maybe this is a little out of what we're talking about, but if you had to build a model which is classifying, but you're not only interested in if the stock is going up or down, but you also like want to make sure you're covering your transaction cost or your trading cost for security. So let's say you only want to trade if it's like greater than 10 basis points, or if you expect the return to be greater than 10 basis points. Like, given the nature of the problem, it seems like a regression model would be a better fit, because if you can predict the return, then only you will know if you should be placing a trade or not. But then with those kinds of models, like you don't really get that good of an accuracy, and you can't really model it like using a classification model. So like, how do you go about it?
Yeah, that's a good question. So in terms of return, when you're trying to predict something, let's say tomorrow, you return tomorrow's stock return, and then the tomorrow's stock return is going to be 1%, 2%, or -1%, or -2%. Then you can categorize them into different classes. So that's what I meant by converting that into classification problem. And the reason to do that is because it depends on what you're trying to do in the very end. If you're using machine to execute those orders, then you can certainly use regression problem, but you still have to make cuts, right? You can't just look at the returns and then expect to make an actual order, right? There's a gap in between that you have to fill in, and you have to make a cut somewhere. And then so the classification step is still made somewhere down the road in your algorithm. It's just whether or not that's in the machine learning algorithm or not. So I still think that cut is made. But Yeah. So to answer your question, it actually depends on what you're trying to do. For me, I have been using, most likely I can tell you it's human enter orders. For machine enter orders, it's going to be very difficult because of flash crash. It works like 2-3 years, and then there's that one day, and then you lost like 20 to 30% of your account value because of flash crash. And I don't know if you guys experienced flash crash with real money before. It's scary. I can tell you it's very scary.
No, it is very scary. Yeah, I have seen one.
Yeah. So you get what I'm trying to say. And then it's gonna be very slow for you to look at the chart and then say, okay, there's a flash crash, and then let me turn the computer off. Once you do that, it's too late. You're already down.
Okay.
Yeah.
Okay.
So definitely. So yeah.
Going back to the problem, if you try to classify it into like more than 2 classes, you're also limiting yourself based on what models you can use. Because if you're trying to use like simple models such as SVM or like linear classifiers or even non-linear classifiers such as decision tree, you can only expect the model to perform well if you're doing like a binary classification problem. As soon as you step up or move into like greater than 2 categories, I think the only option left for you is like some kind of a deep learning model.
Yeah, I actually have one open up. I can show you guys real fast. Hold on, give me 1 sec. Oh, here, okay. Can you guys see my screen?
Yeah.
Okay. Yeah, so that's actually a deep learning model. You load up your data, it's in CSV, or if you want, you can go to Yahoo Finance or load up some API, and then that's your data. And then, of course, you can cut your training data, cut your testing data, do cross validation, things like that. This area is going to be where you build your RNN. Here, I didn't really go that difficult. I just did a long short-term memory. Make sure your input dimension is right, get the data loaded, and then in the end, it comes up with the summary table, which is going to be the architecture of your long short-term memory. And then you fit your model. I didn't do a whole lot. I just did 10 epoch. And then in the end, you plot the training data. If you guys watch carefully, this is actually just, excuse me, this is actually not prediction. This is a training set because this X is X train. If you want, you can have X test here, and then it will print out something in the future. For me personally, I don't really act on machine learning model that's trying to predict the future. I rather act on the machine model predicting the past. If you were to do this on your X test, let's say here instead of X train, you use the X test, then you'll probably expect similar performance like this. But this root mean square error will probably be a little bit larger. And as you can see, this is actually a regression problem, right? There's no different levels. It's all continuous, right? In this case, the continuous variable is price. We're talking about dollar per share, so it's a price. And how do you measure error when it comes to continuous variable? Then you use your root mean square error, which is what I did down here. Usually I will probably just stop here, and then I'll go into the market. I'll look at the chart, and then the chart looks like that. So then I execute my orders. I go to my brokerage account, I execute my orders. I don't. If I were to project this into the future, and then I have to cook up different scenarios. Let's say you project this into the future, then you need to say, okay, if tomorrow I open up my account and the price is gapping up, then what do you do? Or conversely speaking, tomorrow you open up your account, if the market is gapping down, then what do you do? So for me personally, when tomorrow comes, I do my analysis today, and tomorrow shows up 9:30. Market opens. I still go to my brokerage account. I still enter the order manually, just to avoid flash crash, just to avoid, what if today you work out analysis and then you say, hey, I want to buy tomorrow. I'm going to buy this off the morning. But what if tomorrow it gaps up, right? let's say on this day, that's yesterday. Yesterday you say, hey, I did my due diligence, I did my homework, I want to buy. And then tomorrow it gaps up here. Then what do you do? Do you buy? Do you not buy? What do you do? If you buy, it has its tail, it goes down first, and then it shoots back up. Then what do you do? Do you buy? Do you get out? What do you do, right? So there are all these decisions that need to be made. And if you want to cook up a machine that does that, then another question shows up. It depends on where you feed in the data. If you feed in data just the past few weeks, I can almost tell you that's not going to be enough. If you feed in your data for a year, right, or 2 years, doesn't matter how long it is, then there are all these tails that's going to mess up your analysis, right? Because of if you guys take the econometrics, there's this thing called heteroscedasticity, right? The variance here is not going to be same as variance here. The variance here is not going to be same as variance here. So these things are going to mess up what it's going to mess up what you think could be a good performance model. But when you deploy that machine in reality, you actually start to lose money. So so that's why I said that when you do your analysis, like if you can cook up something like that, and if you can do that for each stock, I would say that's a good amount of analysis done in terms of quantitative perspective. And then after that, you just make sure that when you enter your order is done correctly. And when I say correctly, I meant A, efficient. If you want to enter order at 9:30, you shouldn't wait till 9:35. you better get the orders out fast. And then B, with as little price slippage as you possibly can. End of the day, as you guys probably already know, there's not going to be unlimited amount of shares I can buy in the market. Somewhere down the road, it has to stop. Why? Because if you look at the chart, I can turn on my volume bar. That's my volume bar, right? Let's say I'm magic, I'm God, right? I learned I want to buy on this day. Let's say I just magically have a crystal ball. I know how to do that. What's the maximum amount of shares that you can buy? It's 326 million shares. So once your AUM hit a certain level, you're not going to be able to execute that strategy on all of your AUMs. What that means is, as your AUM means assets under management. When your AUM hits a certain level, you are not able to execute the strategy all at one price, because then you're going to single-handedly push the price up yourself. And that's not something that you want. Like if I want to buy the stock at $10, why do I want to push the stock to 15 and then buy it myself? Right? That's not right. Okay. I'm not going to pay extra $5 for like, I don't know, thousands of hundreds of million shares. That's silly, right? That's silly. You don't want to do that. So what's going to happen is you're going to have to start buying on probably this day. And then this day you still buy, this day you still buy. And then the volume of these 3 days adds up together will probably be going to be like 900 million shares. And then that's when you have, and then that's where you build up your positions. So now we're talking about another problem. If the price going down, like, are you insane? Like you still buying, right? You doubling down, tripling down, you still buying. Like on this day, you bought 200 million shares. And then on this day, the stock is going up 10 points and you still want to buy 100 million shares? The investor is going to kill you, right? But then that's exactly the kind of decision that you have to have the balls to make. And that's not going to be something that the machines will help you do that. It's going to be done by you. So let me pause here. Questions about that?
Yeah, I had a quick question on like your data frequency. So if you're building like an LSTM model like the one you showed, like let's say, you know, you have I don't know what the frequency of your data here is, like, but let's say, you know, it's in the like daily or daily. Okay. So let's say you want to like incorporate something like an earnings release in your model, and you want to, you know, like check, I guess, to see like how, you know, the price is impacted by earnings releases, but the earnings releases are a much lower frequency than your daily data. Is there a way you can like effectively weave those two together? And have you like had the opportunity to work with something like that in the past?
Yes, you brought up a very good point. Yes, I have worked on something like that. This is S&P 500. Obviously, it doesn't have earnings, right? It's an ETF. So if you go to an actual company, let's say Apple, and then this is going to be your PB ratio, and that's going to be incorporated with price as well as your fundamentals. PB means price book, right? So this is a price book ratio of Apple. And as you can imagine, since it's book value, right? Then your book value is updated 4 times a year, right? Like there's no more data than that. You have earning, you have a quarterly earning. You look at the quarterly earning update. That's your book value. So this thing is actually updated 4 times a year. So to answer your question, you create this variable called PB ratio, and then usually regular times outside of the earnings season, it's just price divided by book value. Book value stays the same. And then when there's the earnings, you update that book value. So now you have a nice time series that do not have any gaps, right? It's continuous variable. You can throw that into your data. It would just look like there's an extra column here, and then everything follows. That's your variable. You throw that into your machine, and then you trains. Does that make sense?
Yeah, no, that makes a lot of sense. But I guess I'm curious about so I'm currently working on a project where I have order book data that is like second-wise frequency, and we're trying to incorporate some sentiment into it as well. But the sentiment is like a much lower frequency, like let's say on the order of minutes, and so I suppose we could weight like the sentiment by the price, like with the PB that you just showed, but it doesn't seem like it's as straightforward of an application of the idea.
Correct me if I'm wrong. When you talk about sentiment, you mean like a chunk of text?
Yeah, like tweets.
Oh, tweets. Yeah. I'm not so sure if you can do that. You can cook up. You can tokenize it, and then that'll become numbers. And once it's numbers, you can do your magic, put the 2 columns together. For me, I think there could potentially some sort of smoothing that you can do, but then again, you need to weigh out the. You need to make sure that the benefit that you get is not washed out by the noise that you add into your data. So smoothing might not be the perfect candidate for you to do this, but it is one way to fill in the gaps. Another thing is you can leave the gaps as some sort of fixed variable. I don't know if that makes sense to you. Like like let's say I'm like in deep learning, people talk about image classification, right? So image classification. Let's say I want to classify this picture as cat or dog, and I'm not going to use all of the pixels, right? I'm using a certain area of the location in the picture that's just the face of the animal to help me classify the final answer. Which means if you add in the edge as all ones or all zeros, that should not affect your final answer. So it's the same thing when it comes to sentiment. So in sentiment, there's this gray area, and it's very difficult to detect. There's this gray area that you're filling the space in your data with, say, zeros. Zeros shouldn't have any information. So it shouldn't affect your final answer, but it does fill up the gaps in your data frame that you can at least get the machine going. So that's another way to do it.
Okay, yeah, I see. Thank you so much.
Yeah, no problem.
I just had another really quick question. I can see you're using the min-max scaler here instead of the normal, not the standard scaler. Is there a reason behind it, or was it an arbitrary choice?
It's arbitrary choice.
Okay.
Yeah, in an ideal world, you want to run the script, change that, and all these things can be changed. Like, why does it have to be 50, right? There's no reason. You're just gonna have to try it. Why does it have to be 0.2? There's no reason. You have to try it.
Okay.
Yeah. Any questions? That's pretty much all I want to say. I think we're gonna dedicate the rest of the time for questions.
Sure. I had a question about kind of going back to the idea of a test or a training set and like then the test set. Like you said you typically don't have a test set. And could you go more into the reasoning of why and potentially if there is a good ratio between the two, what would it be?
Yeah. So yeah. So let me rephrase that. I prefer not to use a test set, but if I were to treat this as a academic project, I would have done a rolling cross validation. So a rolling cross validation means, you know, let's say this is your data. I'm taking, you know, let's say from here, I'm taking this chunk. Sorry, I'm taking this chunk of data as my training, and then perhaps this as my testing. And then I'm rolling this window a little bit forward, and then I make a mark here, and then I take this as my from here as my training testing cut, and then I move to here. Then I have a vertical bar here, and then I just keep going here, here, here. So if I were to treat as an academic project, I would have done something like that. But then here's a problem. Why do you pick the cut there? Like why can't the cut be here or here or here or here, right?
Mm-hmm.
So my reasoning of not using cross validation or any of these validation methodology that you guys conventionally would do in a data science project is no matter how you do it, unless you have a supercomputer that you exhaustively work out every cuts, right? Then that's a different story. But if we're just talking about regular laptops, like the laptops that we use on a day-to-day basis, not super powerful, then the cuts it's almost guaranteed to be arbitrary, and that's gonna mess up your entry point like this. Because if you're looking at on this day, let's say on this day, and then let me omit this volume. Let's say you're on this day. Right, that looks like crap, right? Why do you want to buy there? That looks like crap. But that's exactly the point that you want to buy. If you look at long run, if I zoom out, that's exactly the day you want to buy, right? So and the reason and how you pick this point is because let me rephrase that. If you want to successfully pick this point by relying on machine learning and carefully measured cross validation, then you better test each of the data point, each of the unit of the data point in your data sets. So when I say unit, I meant, you know, if it's daily data, then you best test every day. If it's a minute data, then you best test every minute. Does that make sense?
Yeah.
So in one sentence to answer your question, the reason I don't want to use it is because the training and validation cut is still made arbitrary by human.
Okay.
Yeah.
That makes a lot of sense. Thank you.
Yeah, no problem.
I had another question, not technical, just about your career.
Sure, go ahead.
Do you think you can talk a little bit about your time at AQR? What were things like? What was the rigor? What did like the company or your team like focus on? A little bit of that.
Sure. Let me see if I can find this online. Can you guys see my screen?
Yep.
Okay. Let me zoom in a little bit. If you guys go to Chem French Data, just Google it, and then you will see this website. And I believe, I think this is something I worked on, operating profit and investment. So if you guys click in this, right, it should give you just like a text file, and that should be the data. Okay, it's going to download something, and then basically it's a data. It's a data frame with like couple of columns. When I was working AQR, the project I was working on is they're going to give. I was given the entire CRSP stock universe data set. It's like a data set that's dating from like 1950s to like 2013 or something like that. And then my job is to look at the data. It's raw data. Clean that up, fill in the blanks, blah, blah, blah. Once it's cleaned up, it's done. I'm looking at these cuts, okay? So when I say cuts, I mean converting or partitioning these continuous variables into different partitions. So for example, operating profitability, that's something you can read from a book, right? And every period, you have these many companies, okay? And then you sort them according to, you can sort them according to anything, but let's say in this case it's operating profitability. Then you can sort them from high to low, and then you can make cuts. And then 25 just means you make 25, you make 24 cuts so that there are 25 chunks, 25 partitions. And the partitions are going to be something that we're interested in, because that actually explains what's the variance in your response variable. I don't think that this field of practice has any machine learning component attached to it. That doesn't mean that you guys shouldn't try it. You guys feel free to try it. But at least when I was working on this, there wasn't any machine learning component to it. It's just a very simple, plain old regression model, except that instead of one regression, you build multiple regressions. And then these regressions, the variables are generated from these partitions. And once that's successful, you can get the project submitted, and then either it gets published or it gets deployed live with real money. And then AQR started taking over from there. That's pretty much how I do it. In terms of teams, usually when a project comes like this, back in the days, I was an analyst, a quant analyst. So my job is to look at the data. I think the language I used was MATLAB. I didn't even use Python on that. It was MATLAB. It was pretty original. It was pretty original. So it was pretty old school. So yeah, so I look at my MATLAB. I come up with the code. I partition the data into a bunch of chunks, bunch of partitions, and then we run a regression. And then I hand that code. I believe I hand that code to an engineer. And then it was to the engineer and to a professor. And then they work their magic. They take it from there. And then either it's right or wrong. If they say it's okay, then we get it submitted. If it's wrong, we come back to the data. We check everything. If there's an error or if something needs to be redone or something like that. But pretty much that's a workflow. Yeah.
Yeah. Thank you for that. And maybe you can also like give us a little bit about why you decided to leave like one of the biggest shops out there and like start your own fund. Like, well, why did you exactly do it? And like, weren't you afraid of like, I don't know, like just going out on your own? Because like, I mean, if you ask anybody and they just say like, oh yeah, it's a really hard market and like making money is just like getting harder every day. Like nobody really like, I don't know, like, I think supports you or like tells you good things about it. So why did you?
Well, there are multiple reasons. There's a direct reason and indirect reason. The direct reason is when I was back in the days, I actually need working visa. So, and we were having some issues there. So unfortunately, I wasn't able to get my working visa. And that's one big reason. That's almost a direct reason. Indirect reason, I think if I were to have my working visa and you know, I was able to legally stay there, I think I will probably still end up leaving in like a year or so, because if you look at if you think about this problem, if you think about asset pricing in machine learning point of view, if you're capable of introducing the first three factors, you're golden. You won Nobel Prize, you're done. Like you're done for your entire life. But when you're getting to like the 20th or the 30th factor, the 30th variable, sure, there's some alpha generated, right? Like we're talking about an alpha that's probably like 0.0001%. And A is not going to pay your lunch, right? B, it's too costly. We're talking about having a room full of PhD students work out all the MATLAB code, getting the model deployed, and making sure traders execute the orders correctly, and then we're generating 0.001% alpha. That's probably not going to be enough of alpha generated to pay for that kind of a cost, right? So there's a classical economic argument here. Eventually down the road, when you're having too many variables introduced in your factor-based trading algorithm, you're hitting an area where you have marginal cost exceeds your marginal benefit, okay? And that's exactly the problem that AQR is heading in right now. And that almost, either they completely abandons their belief on factor-based trading algorithm and move on to deep learning, or if they don't want to do that, then that's going to be the direction they're heading to. They're heading to a direction that the marginal cost is exceeding marginal benefit, and that's a loser's game. And I thought to myself, I was young, right? At that time, I was very young. I was like 22 or something, 22, 23. So if I'm betting my next 10 to 20 years on something, on a career path, I'm not going to bet that on a career path that's going to end in 5 years, right? That doesn't make any sense. So yeah, so that's the indirect reason why I left. Did that answer your question?
Yeah. I just wanted to know, like, what was your mindset and why did you leave? Because, you know, like, people, I think they work most of their lives to get like work for a company like AQR. So like it was I think kind of interesting to like know why did you want to like leave and then go out on your own.
Yeah. That's pretty much the big reason out there. I think end of the day you wanna keep an open mindset. I'm not saying that asset pricing is bad. That's not what I'm saying. I'm saying asset pricing is good. If you can work out one of these models, you're in pretty good shape. You can pretty much figure out everything yourself. So yeah, so if you guys can get in there, find a permanent position, a full-time position, and you like it, and definitely stay. There's no, I'm not saying don't do that. What I'm trying to say is, when it comes to making that final decision of which direction your research and development is going, you shouldn't just come out and put a hard no on the field. I feel like that's sort of like the direction that they're trying to take. I don't know if they're doing it right now. I'm not saying they are. But back in the days when I was there, deep learning was not touched at all. And again, I'm not saying deep learning is a golden ticket that can magically solve everything, right? That's not what I'm trying to say. But I think at least it's worth a shot, right? At least it's worth a try. You should at least touch on that. So yeah, so that was the direction that unfortunately they took back in the days when I was there. Deep learning was not touched at all. Mostly just plain old regression problem, and then they're relying on cutting data into different partitions. Yeah. So I would say that's the biggest reason. Yeah.
Can you speak a bit about why you chose to pursue a statistics PhD?
Yes. When I was working on my first deep learning model, I realized a lot of deep learning practice is just taking random shots in the air, and I was sort of like getting tired of that, because I don't think deep learning should be a rich person's game. I think everybody should be able to do that. But of course, if you're rich and you can afford better computers, you can afford parallel computing, please go do that. I'm not saying don't do that. If you have the resources, no, of course do that. But back in the days, I didn't have a whole lot of money to afford better computers. In the old days, my laptop was like $400, and as you guys can probably imagine, $400 is not going to get you a A+ laptop. It's probably going to be a very shitty laptop. So a lot of the deep learning practice that I was trying to learn from, or at least I thought was what I was trying to learn from, was mostly just changing your parameters and then run your models and then magically hope that performance getting up. And I was sort of like getting tired of that, and I thought to myself, geez, there's got to be a better way, right? Like you shouldn't rely on powerful computer. you shouldn't rely on money. Like you should rely on the actual understanding of data and understanding of the methodologies behind these learning model. So if you take a deeper look, most of the learning models out there, it's either a optimization problem or iterative problem. But they're pretty much two ways, or a combination of these two. You either, if you don't know the answer, you try many, many times, right? That's one way. Another way is you have a loss function. You know what your error is. You try to mitigate that loss. You try to decrease your error. Then that's an optimization problem, right? You set up a loop, you run many, many times. Every time the error gets smaller, right? There's gotta be some sort of statistical idea behind how these two algorithms are working and why they are working. Instead of just, if 100 rounds don't work, then let me try 200 rounds. If 200 rounds don't work, let me try 400 rounds. I mean, if that's how you think about things, then you should be able to dump millions of dollars, billions of dollars before you can see an actual result. And still, there's no guarantee that there's a result. So really, I think to really make some progress, you really have to understand the problem from a statistical standpoint, which is why I turned my attention to stats. Yeah.
Yeah, thank you so much.
Yeah, no problem.
Yep, thank you so much, man. This has been incredible. A lot of insights
here. Yeah, no problem. Yeah, it's my pleasure.
Yeah, one final thing I'll say is that Dominic was the winner of the training competition. So congrats to Dominic. He had the best returning portfolio.
So great. Yeah, congrats.
He won a $120 prize for Dominic.
Thanks.
Yeah. So yeah, you guys are free to go. And thank you so much for coming. We really appreciate it. And this will definitely be something that we learned a lot from.
Thank you very much. Have a good one.
Yep.
Peace out, Zach.
Yep.
See you guys.
Yeah.
See you, Joey.
Yeah, it's a great pleasure. Yeah, take care.
Thanks so much. A lot.
Thanks for your time.
Yeah, no problem. Yeah, take care.
You too.
All right, Zach. Do you have more questions or?
I think a lot of my questions were asked like pretty much. I was curious about obviously your career path and everything that was talked about. I'm trying to think. I would be curious, like, what do you think of like supervised versus unsupervised learning? Like, because I think a lot of discretionary traders are looking and they're thinking, man, maybe supervised learning, I can feed my track record in and teach a machine to trade like me. Do you think that's a viable approach or not?
Yes, it's I mean, in theory, yes, it should work, but it's a little bit hard. I'm not so sure if the difference between supervised learning and unsupervised learning. It's always supervised. Supervised just means you have a label. You have your X and you have your Y. That's supervised. I think what you're trying to get might be reinforcement learning. Reinforcement learning actually, I think it pretty much does what you're talking about. You know, like tic-tac-toe can be done with reinforcement learning. You can just like Google the code, and then they're like Python code or R code. They're online, and then you can learn from that. Yeah, and then self-driving car can also be done with reinforcement learning. In the sense that I mean, the problem setup is very simple, right? You have an agent, and then the agent has some sort of actions, and then each action that this agent takes, there's a reward or a loss, or it can be multiple levels. It doesn't have to be binary. It could be reward 1, 2, 3, loss 1, 2, 3, something like that. Like you can define yourself.
Mm-hmm.
And then the data is simple. The data is just time series data. You know, stock price go up and down. And then if it buys here, there's a reward, there's a loss. If it buys there, it's a reward, there's a loss. I would say the difficult thing here is the definition of reward and loss is going to be very difficult to define according to your action. because we talk about in a chart, you know, if you decide to buy today, then if tomorrow gaps up, what do you do? If tomorrow gaps down, what do you do? Or if tomorrow's flat and you bought it and it goes down, then what do you do, right? These actions exponentially increase. And if the actions exponentially increase, then your reward and loss also exponentially increase. Then you're heading into a direction where you have very little X, and then your Y is like thousands of levels. Yeah. So right. So now you're entering into a field where theoretically the machine learning algorithm will run. In this case, the reinforcement learning. But in practice, you're entering into a field where you're probably going to be a lack of data. That's my guess.
Mm-hmm.
Unless you have good data, and then you somehow refine your action and your reward into like 2-3 levels. But if you do that, then you better defend. You better be able to defend why do you define in these 2-3 levels, right? Otherwise, it's going to be difficult to execute that with real money, you know.
Yeah, and you also have the problem of if you're using a greedy algorithm to maximize reward, you may overlook a low probability, high reward scenario in that situation.
Yeah,
that seems to be the overall trend with machine learning, is like it's somewhat susceptible to like overfitting, and that seems to be like its main weakness, I would say, applied to financial time series, because you only have a finite amount and there's so many different ways that you can overfit by accident.
Yeah.
Have you had any issues with overfitting in the strategies that you've developed?
Overfitting, yes. Short answer is yes. Eventually, you're always going to run into, some sort of overfitting. There are a couple of ways you can do. If you stick with textbook, then you can introduce regularization, you can introduce dropout, you can introduce dimension reduction, feature selection, you know, all these fancy stuff. Pretty much you can see from textbook. For me, if it's not an academic project, right? If it's just something that you're doing for yourself, I would say if you see an overfitting problem, it's almost always the problem from the data itself. Then you better have a new X and have a new Y. That's my take. Because I've been getting myself into a situation, or I was in a situation that I thought it's just another regularization that I have not tried. But you know, it turned out that when you set up the parallel computing and then you try it, you throw that on the cluster, and then once you finish running, like 4 weeks later, it's not right. I want to bring it up to your attention that it's always good to try to avoid this kind of stuff before you rely on computer to figure out what a mistake is. Like you should be able to have a sense of where you could potentially make a mistake before you let the computer tell you where you make a mistake, right?
Yeah. So what do you think of Monte Carlo simulation then? Do you think it's potentially falling for that trap that you just mentioned?
Monte Carlo, I think it's a good model on paper. I don't really trade off that model. I think it's a little difficult to trade. If you project like people do like billions or millions of simulations, I mean, I think that's a little bit overkill. Even if you do thousands of iterations, it's still a little bit hard to trade off that, because then you're gonna have 1,000 different sets of actions, and then chances are there's going to be overlap, right? Because if you look at a Monte Carlo projection, and then the top 2 lines, really, what's the difference between the top 2 lines? So I think like end of day is getting into an area that's a little bit overkill on the algorithm, but the actual benefit delivered is probably a minimum. So yes, you definitely want to avoid those areas for yourself, as well as for for your time, because you're not doing this full time, and hopefully in the future you get paid to do this. But right now, we're not getting paid to do this, right? Then why waste the time?
Yeah, that makes sense. Thank you.
Yeah, no problem.
I've read that the Monte Carlo models are like more used for like, let's say your strategy is like writing options and you want to like simulate, the relative likelihoods of like certain events happening. I don't know if that that makes it like a more viable thing. But I wanted to ask, because like Zach and I are working on this this project right now, and we're like trying to forecast cryptocurrency prices. And so you talked about this, like the issues with using the rolling window for like train tests, because you're always sort of biasing your sample set by cutting off, you know, by making that arbitrary cutoff. And I was just curious because we had this idea of separating, you know, segments of the time series into like similar clusters. So let's say you have, you know, a very like bullish, you know, 30-minute period, a bearish 30-minute period, you know, maybe one with high volatility but is neutral, low volatility. Like, you know, if you can somehow, you know, segment the time series and then trade on, you know, those segments, if you recognize them, you know, having occurred, you know, live, then does that kind of help, you know, go around the problem of biasing your sample set with the window? I guess it's a very complicated question. And then, so
you might have to quantify that a little bit for me. What do you mean by segmenting it?
Right. So let's say we have 30 minutes of, you know, price data, and the frequency is, let's say, you know, 1 minute.
Okay.
We will, let's say, you know, take some arbitrary, like, I guess, summary of this region. You know, we can take like maybe, you know, we can take maybe every data point, and we have a vector of size 30, or maybe every other one we you know, can have like faster training time. But let's say we take, you know, every third data point, we have a vector of size 10 that kind of represents, you know, the price every 3 minutes. And we, you know, take subsets of our big long time series that are, you know, 30 minutes in length. We summarize them with these 10 data points, and then we feed them to a k-means or some sort of other segmentation algorithm that will, you know, in an unsupervised fashion, you know, say, okay, well, this time series, you know, this 30-minute period is part of, you know, some type A, and this other 30-minute period is of some type B, and so on, you know, however many classes we set. And so then when we fit, you know, an LSTM on the data, you know, it's seeing a similar type of series every time because it has, you know, let's say a similar pattern over that 30-minute period.
Let me think about this. If it's unsupervised, you don't have label, right? Or did you say?
Well, so it's sort of a two-stage process.
Okay.
In that, like, we would have the unsupervised component would occur first, and we would segment the time series, you know, into different, you know, chunks in some sense, and then, you know, each chunk we say, okay, well, you know, this one looks kind of like it's going up, this one looks kind of like it's going down, you know, this one, you know, does some other behavior, you know, maybe it, you know, it makes, you know, some kind of like a follow like a Gaussian like shape, you know.
Okay.
They have some type of behavior, and then you train a different LSTM on all the subsequences that look of a similar form. Was kind of the idea we had.
I see. Yeah. Just to echo the point I was making, when you select the 30-minute window, either you sample it and then you do it many times, or I think a safer way is probably to do it exhaustive. Like exhaustive
means that at every single
minute you roll the window. Yeah. I think that might be a safer way. Otherwise, there's going to be some pattern generated that you know, perhaps fit for the first 15 minutes, but then, you know, the last 15 minutes you screwed up.
Yeah. Okay. Yeah. I see.
Yeah.
And is there a reason like you use Keras instead of like something like PyTorch? It's just because the API is simpler, or because I know a lot of people like PyTorch because of like the dynamic graph and other things like that. And I'm sort of curious why you like Keras.
There isn't really a whole big reason. When I first got started, I was taught using TensorFlow in a Keras environment. So I kind of just like sort of stick with that. I believe I used PyTorch before. I also used MXNet before. Me personally, I think based on what I'm doing like right now, I actually don't really use a whole lot of package itself. Most of my work is well, it actually depends. If it's for myself, then whatever package works, and then it works. If it's for research purpose, then the problem we're trying to solve right now, I don't think any library will help to solve that, because when you're talking about a library, everything is hard coded in between, and then it's difficult to break the package up. Unfortunately, like when you go into PhD program, probably I will say like most of the problems, if not all of the problems, can like usually they either don't have answer, or you're gonna have to recode everything yourself. Because if it can be solved with an actual package downloaded, then what's the point of PhD, right? Yeah. So unfortunately, for me personally, most of my work right now, I have to code package like from like paper. So I have to recode everything. Yeah.
That's tough. Yeah, I guess I have one more thing I wanted to ask. Like,
sure.
do you think like, is it like, do you find meaning in like applying these types of like data science techniques to financial problems, or like, do you think it's more meaningful like because I know like a lot of people, like, they complain that oh, the hedge funds and the high frequency traders are like snatching up all these really bright people from universities, and like instead of them solving the world's problems, they're figuring out ways to make money. And I'm just curious, like, what kind of thought you might have on that point. Like, did you find it like meaningful, and like, do you find it meaningful to work on these sorts of like financial time series like forecasting problems, that everyone's been working on for the past 50 years, or because I know you work at Bayer now, and like is that like is that more interesting to you? I'm kind of curious how like your taste has evolved over time.
That's a good question. I think the short answer is they're actually quite different. It's sort of like comparing, like, it sort of feels like comparing apples with oranges. I'm not sure if AQR and Bayer have a fair comparison on the table. If you're just talking about coding itself, of course there's a overlap, right? You both use Python, you both have to deal with data frames, that sort of thing. That's of course the same. Machine learning, right? Of course that's the same. You use neural network here, you use neural network there. Right? This stuff is the same. In terms of actual value, I would say Bayer probably have a little bit higher social value than AQR. I think if you're heading to a company like AQR, you have to keep in mind that end of the day you're making some rich dudes richer. That's gonna be like how things go. And then hopefully, ideally, somewhere down the road, you show him your performance and he writes you a nice fat check, right? If things work out, if you're able to stay at one of these firms for like the next 10-20 years, you should be all set. Like if you're able to getting AQR, and if you're able to get yourself promoted, not even a whole lot of time, just I would say twice. The first one from analyst to associate, and then the second time from associate to a VP or something. And then if you're staying VP for like 5 to 7 years, on top of the first 3 to 4 years of the time when you're associate, then you should be all set for the rest of your life. Really, it's not a like it's a nice track if you can. Not many people can hit it. If you can make it out of that, it's very nice. It doesn't have to be AQR. A lot of the firms on Wall Street have this sort of track. Goldman Sachs, BlackRock, they all have similar positions. But yeah, but end of the day, you're making some dude richer, some rich dude richer. That's really what it comes down to. And for me personally, I hope that, and that's just my hope. I hope smart people that have a capability and brain power to get into AQR, to get into Goldman Sachs and BlackRock, if they contribute their intelligence somewhere else, perhaps this country will be much better. But that's just my hope. There's no scientific grounds for that. There's no. It's just my personal hope. For me, if I'm giving you guys a recommendation, I would say the first job really you probably take whatever you can get, right? That's, you know, what we're talking about reality here, because you need to pay the rent, you need to pay your bills, right? Then the first job, you're probably just going to get whatever you can get, and then pretty much start from second or third job. And when you're getting to late 20s, then you probably need to think about this kind of stuff, right? The next 10, 20 years of your future, like, do you want to dedicate yourself in, like, what kind of field do you want to dedicate yourself in, and what's the reason behind that? And you need to, like, you shouldn't be heading down a road that when you're in your 40s and you want to switch career and you can no longer do that, and then you regret yourself. That shouldn't happen. To avoid that from happening, then you better think this through when you're in your 20s.
Yeah, cool. Thank you. That was a really great answer. I appreciate it.
Yeah, no problem.
Yeah, very interesting perspective. I think that's something a lot of us are struggling with too. So it's good to hear your perspective on that.
Yeah. You guys don't have to worry about visa, right?
No,
Okay.
not in my case, at least.
Okay. Yeah, then yeah. I mean, go ahead. Apply for as many companies as you can. And yeah, just try your best to land that first job first. And then starting from there, either work your way up if you like the industry, or think about what you want to do for the next 20 years. For me, I mean, I'm not completely set on Bayer. I mean, Bayer is a great company, but it's in agricultural. I think there's a lot of value in there. People need to eat, right? You go to grocery store, you need to buy stuff. That's, you know, we do that every week. So I think there's definitely value, but I'm not sure if I find it interesting enough to be able to do it for the next 20 years. I think for me personally, I definitely want to stay in data science, but probably gonna end up doing some sort of quant related stuff, either in technology sector or financial sector, but some sort of technology related stuff. I'm probably, I mean, I'm going to try my best to not end up in a quant firm again, but yeah, but if things comes to worse, if I had to get back to financial or like one of the quant firms on Wall Street, then I mean, I'll probably do that. You know, just because you have to pay rent and you have to pay bills and that sort of thing. But yeah, but overall, I still like stock market myself. That's why I'm keeping, like, I kept doing this Ying's Capital thing on a side gig, as a side gig, that I just find it interesting. Yeah, that's pretty much it. Yeah.
Yeah, that's cool. That's cool. I mean, I'm out of questions, Zach. But thank you for having Yin on. Like, it was really great. I really enjoyed this presentation. Definitely a highlight of the semester. So yeah.
Oh, thanks.
Cool.
Appreciate it. Yeah.
Yeah, likewise.
Yeah, no, it was really awesome.
Thanks. Appreciate it. Yeah. Well, let me know if you have more questions. Feel free to add me on LinkedIn, Facebook, that sort of thing. Yeah, just shoot me a message for something if you have questions.
Cool. Yeah, we'll do.
Yep, we'll do, man.
All right. Well, you guys have a good night. Yeah. Thank you so much.
Thanks a lot.
Yeah. Thanks. Yeah. Appreciate it. Yeah. Have a good night.
Yeah. Peace out.
All right.
Yeah.
Bye.